Good day. So I am going to solve one problem in mechanics of deformable bodies, and it is about stress. So the problem is, knowing that the angle theta is 40 degrees and P is equal to 9 kilonewton, determine A, the smallest allowable diameter of the pin, at B, if the average shearing stress in the pin is not to exceed 120 megapascal, and B, the corresponding average bearing stress in member A at B, and C, the corresponding average bearing stress in each of the support brackets at B. So this is the figure. To look at it easily, we need to draw the figure. So when we redraw the figure, in geometry, it is an isosceles triangle with two sides from drawing, so the angle opposite to each side is also from drawing. Angle theta here is 40 degrees, and the angle here is 140 degrees. And here is 120 degrees. And here is 20 degrees. And here's point A, point B, and point C. So now that we have to draw the figure, we're going to draw an FBD of the reaction that happened here. So this is the force P exerted at joint A. And this is the force FB opposing the force P. And this is force AC pulling away to have an equilibrium. So we have angle of 20 degrees here, and this part 50 degrees because this is 40 plus right angle, so this is 90, so to make it 180, this is 50 degrees. And this part here is 110. So a total of 180 degrees. So after we draw the FBD at A, we're going to find the force at member AB because the problem is asking for B. So P is equal to 9 kilonewton and force AB is still unknown. So to do that, we're going to draw a force triangle to solve force AB. So this is P. So 110 plus 50 minus 180 is equal to 20 degrees. So with this, we can use the sine law to find force AB. So P is equal to over sine 20 degrees is equal to FAB is equal to sine 1 force AB is equal to sine 110 is equal to P. P is equal to 9 kilonewton. 9 over sine 20 degrees. What about both sides? So cancel. So here we have 9 sine 110 degrees over sine 20. Force AB is equal to So we have 24.73 kilonewton. So now that we have our force AB, we can now solve the smallest diameter at pin B. We're going to use the shear formula. So shear stress is equal to force over A, area. And since it is a double shear, we have a 2 here. Can be written also as force is equal to 2. Area is pi over 4 d squared. Shear stress is equal to force AB is equal to 2 times pi over 4 d squared. So in the problem, the shear stress is 120 megapascal times 10 to the power of 6 is equal to, and force FB is equal to 24.73 times 10 to the power of 3 and 2 d squared, and our d here is unknown, and we're going to solve for d. So using cross multiplication, we can find d. So d squared is equal to 24.73 times 10 to the power of 3 over 120 times 10 to the power of 6 over, and we have 5. D squared is equal to 131. Then the power of -6 square root we have d is equal to 11.45 meter. So the smallest allowable diameter at pin B is 11.45 millimeter. So at B, so we're going to use the bearing stress formula. So bearing stress is equal to force is equal to area. And this can also be written as EB is equal to thickness times diameter. So bearing stress is equal to force AB and thickness over diameter. The bearing stress is equal to 24.73 times 10 to the power of 3 over thickness is 16 millimeters, so converted to meter is equal to 0.016 meter. 0.016 meter. And the diameter we're going to use this, so 11.45 times 10 to the power 3. So bearing stress is 134.9 mega Pascal. So now we're going to solve for the bearing stress in each the support brackets. So we're going to use the bearing formula. Bearing stress is equal to TB over area. B. We have two brackets and the force is divided into half. We have 1/2 of the force. So bearing stress is equal to 1/2 force F AB over thickness times length. Bearing stress of 1/2 24.73 times 10 to the power of 3 with a thickness of 0.12 and diameter of 11.45 -3. So we have bearing stress is 89.99 times 10 to the power of or is equal to 90 megapascal. So in this problem, we have solved all the questions and the smallest allowable diameter in at B is 11.45 millimeter and the bearing stress AB at B is equal to 134.9 megapascals and C, the bearing stress in each support brackets is 90 megapascals. That's all. Thank you.